So I want you to think about just the fundamental nature of a traditional gas-powered car for a second.
Okay, sure.
It's essentially, well, it's like a mechanical island, right? You pull up to a pump, you pour combustible liquid into a tank, it burns it, and then you just drive away.
Yeah, completely disconnected.
Right. That vehicle has zero relationship with the electrical panel in your hallway or, the power grid of your city. It exists completely off the grid.
Right, until now.
Exactly. Because the moment you bring an electric vehicle home, that isolation just ends. Suddenly, your car is like the largest electrical appliance you own.
Oh, by far.
And it has to be deeply integrated into the nervous system of your daily life.
Yeah, and we are witnessing a massive rewiring of how human beings interact with energy on a personal level.
Yeah.
I mean, if you were tuning in, you were probably already past the philosophical debates about whether the shift is happening.
Oh, absolutely. Transition is here.
It is. So today, we are taking our sources to look strictly at the physical, the logistical realities of making this global electric vehicle rollout actually function.
Yeah, and to do that, we are tearing into field notes from two just wildly different physical environments.
That's a great comparison.
It really is. So on one side of the globe, we have insights from a source called RAA Daily, and they're chronicling the massive infrastructure rollouts by South Australia's Mobility Association across an incredibly vast, sprawling landscape.
Right, huge distances.
Massive. And then on the other side, we have a blog called Watt Charge Mobility's Insights, detailing the high-density, high-rise urban EV challenges in Dubai and the broader United Arab Emirates.
Which provides just a fascinating contrast because, the lithium-ion chemistry of the battery sits inside the car doing the exact same thing in both places.
Right, a battery is a battery.
Exactly. But the human environment surrounding that car dictates completely different infrastructure solutions.
So true. So let's start this deep dive where the transition actually begins for most of you, which is bringing the car home. We're looking at Dubai here.
The private charging puzzle.
Right. If you buy an EV in Dubai, you are immediately forced to solve that private charging puzzle. And the sources break down your two primary choices. First, you have level 1 charging, which is basically taking a cord and plugging it into a standard wall socket in your garage.
Which is going to take anywhere from 8 to 20 hours to get a full charge.
Yeah, 20 hours?
I mean, that is physically comparable to trying to fill an Olympic swimming pool using a standard garden hose.
That's a great visual.
Yeah, the flow rate of electricity coming out of a standard wall outlet is simply too small for the massive capacity of an EV battery.
Right. I mean, it works if you drive a few miles a day, maybe.
Sure, but for a serious commuter, it is completely unsustainable.
And that reality pushes almost everyone to install a level 2 charger, which dramatically cuts that charge time down to a manageable, say, 4 to 8 hours.
Yeah, usually an overnight charge.
Right. Okay, let's unpack this, because if someone tells me I need to buy a level 2 charger, I picture like walking into an electronics store, buying a heavy-duty power brick, and just plugging it in.
Oh, if only it were that simple.
Right. But reading through the Watt Charge insights, doing this in Dubai reads less like buying a phone charger and more like taking on a minor home renovation.
It absolutely is a renovation because you are fundamentally altering your property's electrical load. I mean, in Dubai, a level 2 charger unit itself costs between 2,500 and 7,000 dirhams.
Okay, that's just for the box on the wall.
Just the box. But the total estimated cost, once you factor in installation and the necessary electrical upgrades, that jumps to anywhere between 4,000 and 10,000 dirhams for an apartment building.
Wow.
And it can go up to 12,000 dirhams for a villa.
Wait, I have to stop you there because 12,000 dirhams is over 3,000 US dollars.
Yeah, it's a significant investment.
I am genuinely struggling to understand why running a wire a few feet from a breaker box to a parking spot costs that much money. What is actually happening behind the drywall?
Well, consider the physical limits of the infrastructure. The electrical load isn't just about how much money you pay on your utility bill.
Okay.
It is a physical ceiling on the capacity of the copper wires running beneath the street.
Ah, I see.
So when a 100-unit apartment building was constructed, say, 10 or 15 years ago, the architects calculated a very specific electrical budget for lights, air conditioning, and ovens.
Right. Things they knew people would use.
Exactly. They did not budget for 50 residents suddenly plugging in industrial-scale power drawers in the basement garage.
So it's essentially a plumbing problem. Like if one person opens a faucet, the water pressure is totally fine.
Yep.
But if 50 people open fire hydrants simultaneously in the basement, the water pressure for the whole building just drops to 0.
That's a perfect analogy. And the electrical equivalent of that water pressure dropping is the building's main transformer melting down.
Oh, wow. Or the neighborhood grid blowing out.
Exactly. And this is why the bureaucracy in Dubai is so intense around this. You can't just plug it in. You need a site assessment. You need approvals from DLIA, which is the Dubai Electricity and Water Authority,
Yeah.
and you need permission from building management.
That sounds exhausting.
It is, but they have to carefully evaluate if the local grid can handle that much sustained energy draw. And often, electricians have to run entirely new, thick-gauge wiring all the way from the main utility feed just to reach your specific parking spot safely.
Okay, that makes the cost make a lot more sense. But the sources do highlight that clearing all those bureaucratic hurdles is actually worth it financially in the long run.
Oh, without a doubt.
Yeah, because charging a standard 60 kilowatt hour battery at home in Dubai costs about 14 to 22 dirhams for full charge.
Which is incredibly cheap.
Right. When you contrast that with a petrol car, which typically runs a driver about 600 to 1200 dirhams monthly, the math heavily favors making that upfront investment.
It really does. And beyond the wallet, there is a fundamental chemical payoff to doing it this way.
What do you mean?
Well, home charging is scientifically the best way to preserve your battery's health over its lifetime.
Wait, why does the battery care where it gets its electricity from? Isn't a watt just a watt?
A watt is a watt, yeah. But the speed at which you force those watts into the battery changes the physical environment.
Okay, how so?
Fast charging shoves incredible amounts of energy into the battery cells very quickly. This creates immense electrical resistance, and resistance creates heat.
And heat is bad for batteries.
Heat is the natural enemy of lithium-ion chemistry. It can cause micro-cracking in the internal structure of the battery cells, which permanently reduces how much charge they can hold over time.
Oh, so you're actually degrading the battery faster.
Exactly. Whereas slow, steady level 2 charging overnight at home generates very little heat. It is kind of like a gentle rain soaking into the soil, whereas rapid charging is like a flash flood that slowly erodes the topsoil away.
That makes total sense. That's a really good way to think about it. But we have a major bottleneck here.
Yeah, we do.
What happens if you live in one of these older high-rises in Dubai and the building manager flat out denies your request because the electrical panel is already maxed out?
It happens all the time.
Or, stepping away from individuals, what happens if you manage a logistics business with 50 electric delivery vans operating in the heart of the city? You can't just plug them all into a 1990s warehouse wall.
No, you definitely can't. And that's where the sheer density of Dubai forces a completely different approach.
Right.
If you cannot physically build the infrastructure to the car, the market adapts by bringing the infrastructure directly to the car.
Yes, enter mobile EV charging. And the sources highlight companies like Watt Charge Mobility's rolling out these on-demand charging vans.
Which is just wild to think about.
It is. You can literally order a charge from a smartphone app. A specialized van pulls up to your parked vehicle in a lot and juices up your battery while you are sitting upstairs in a meeting.
It's a huge shift in how we think about refueling.
It is, but I need to push back on this concept for a second.
Okay, go for it.
Is deploying trucks to charge cars just a temporary band-aid shifting the bottleneck? Or is this mobile on-demand model the ultimate permanent flexibility hack for dense cities? Because dispatching a heavy van, likely burning diesel, to navigate through thick Dubai traffic just to plug a cable into a parked car for an hour sounds incredibly inefficient.
I get that. But what's fascinating here is that in a hyper-dense environment, convenience actually functions as infrastructure.
Interesting. How so?
Well, retrofitting underground concrete parking garages across an entire metropolis might take decades, assuming the local grid limits even allow it. Mobile charging bypasses that wait entirely.
Okay, that's fair.
And for fleet management, it is nothing short of a game changer when you factor in the cost of lost time.
How does lost time factor into the vans, like the delivery vans?
Think about a delivery driver. Every minute that electric delivery truck sits idle at a public charging station in the middle of a shift, the logistics company is bleeding revenue.
Oh, because they're paying the driver.
Right. They're paying the driver an hourly wage to basically sit and drink coffee while the battery charges, and that truck isn't moving packages.
Yeah, that's a lot of wasted money.
With mobile charging, the power comes directly to the fleet depot overnight, or a charging van meets the trucks at the loading dock while they're being packed for the next shift. It means zero downtime.
Ah, I see. And the sources refer to this as a hybrid model for urban fleets, right?
Exactly.
So a logistics company combines whatever limited depot chargers they are allowed to install for daily operations, Then they utilize public fast chargers strictly for long, out-of-town routes.
Right, keep them on the road.
And then they rely on mobile charging to eliminate the rest of their downtime.
It's incredibly efficient when you look at the whole system.
Now, sending a van to rescue a low battery works perfectly when millions of people are packed tightly into a high-rise metropolis. But if I am driving an EV and I get stranded in the middle of the Australian outback...
Oh, yeah. Totally different story.
Right. Dispatching a mobile charging van from a city center would take 3 days to reach me. That logic completely falls apart.
It does. And South Australia represents the exact opposite physical challenge. You are no longer dealing with the intricacies of underground concrete garages or local building managers.
No.
You are dealing with thousands of kilometers of open road stretching between isolated regional hubs.
Which brings us into the insights from REA Daily. The RAA, which is South Australia's Mobility Association, is tackling this monumental engineering project.
It's massive.
They are constructing the state's first border-to-border EV charging network. The updates in the source material outline their progress in completing vital tourism routes.
Like the Coastal Drive.
Yeah, they are connecting sprawling regions like Kangaroo Island to Coffin Bay, and they are aggressively closing the massive infrastructure gap on the South Australia to Western Australia crossing.
And to bridge those distances, the technology deployed has to be significantly more robust than a home charger in Dubai. The RAA is trenching in 150 kilowatt rapid chargers. And they're even deploying ultra-rapid 200 kilowatt charging sites in strategic regional hubs like Mount Barker and the Riverland.
Let's frame that 200 kilowatt number for the listener, because if a level 2 home charger is drawing maybe 7 to 11 kilowatts and taking 8 hours, what does 200 kilowatts actually feel like for a driver pulling off the highway?
Well, it shrinks the charging window from an overnight event to roughly 20 minutes.
Wow, 20 minutes.
Yeah. It is essentially the time it takes to walk into a roadhouse, use the restroom, grab a coffee, and stretch your legs.
So like a normal gas station stop.
Exactly. By the time you return to the vehicle, it has pulled enough energy from the grid to cover another few hundred kilometers.
Here's where it gets really interesting, though. There is a profound historical echo happening with the RAA right now in the source material.
Oh, the founding of the RAA.
Yes. They were founded over 120 years ago. And their original purpose was carrying heavy petrol cans out into the rugged bush to rescue South Australia's very first motorists, who were absolutely terrified of running out of fuel because gas stations barely existed.
It's amazing how history repeats itself.
Right. Today, a century later, they are doing the exact same thing. They are building out a network and deploying their own electric patrol vans equipped with mobile EV chargers for stranded drivers. They are just rescuing people with electrons instead of gasoline.
And connecting the Dubai fleet manager to the tourist on the Eyre Peninsula in South Australia reveals a universal truth about technological adoption.
What's that?
The primary barrier is rarely the technology itself. It is the deep-seated psychological fear of being stranded.
Range anxiety.
Exactly. Once you solve that human anxiety, whether by having a van pull up to your office in the UAE or placing an ultra-rapid charger at an outback roadhouse, the physical adoption of the technology follows rapidly.
So, the concrete is being poured and the chargers are finally in the ground globally. We are solving the hardware problem.
Slowly but surely, yes.
But the sources point out we are now hitting a really messy friction point, which is human etiquette. We are forcing millions of drivers to unlearn a century of ingrained behavior.
Yeah, because the traditional gas station model conditioned us to pull up, hold a pump handle for 3 minutes, and immediately vacate the physical space.
You get your gas and you get out.
Right. EV charging fundamentally breaks that flow. Even at rapid speeds, you are occupying a highly coveted parking spot for 20 to 40 minutes.
And you just leave your car there.
Exactly. You are free to walk away from the vehicle.
And the sources show that our social manners are completely failing to keep up with the technology. Like, in the UAE, experts are actively pleading with drivers to use public fast chargers sparingly.
They really are.
They note the cost is around 38 fills per kilowatt hour, but the real issue is that if everyone treats the public fast charger as their primary energy source, the entire network just clogs up.
It creates a massive bottleneck. And in South Australia, this sharing problem has escalated to the point where pleading is no longer effective.
People just weren't listening.
Nope. So the RAA had to implement financial penalties. Starting February 1st, they introduced strict idle fees for drivers who leave their vehicles plugged into public stations after the battery has reached its limit.
I mean, leaving your fully charged EV plugged into a public station is the modern equivalent of leaving your laundry sitting in the communal dryer for 3 days.
That is exactly what it's like.
These new idle fees are essentially the financial version of an angry neighbor's sticky note.
That's a hilarious way to put it, but it's true. The grid demands flow and efficiency.
Right.
Public fast chargers are engineered for topping up on a long journey, not for storing a vehicle while you run errands or go to a movie.
Definitely not a parking spot.
Right. And these behavioral nudges hitting people in the wallet with idle fees are the necessary growing pains for a functioning ecosystem. The infrastructure only works if the humans agree on how to share it.
So we figure out the wiring in our apartments, we figure out how to share the public spaces, and we get millions of these vehicles on the road. This leads to the most significant logistical hurdle in our deep dive today.
The grid impact.
Yeah. What physically happens to a city's power grid when millions of these massive rolling batteries all come home and plug into the wall at 6:00 p.m.?
That specific scenario is the nightmare of every utility operator on Earth.
I can imagine.
Because electricity is not something that just floats in the wires waiting to be used. It must be consumed the exact microsecond it is generated at the power plant, unless you have massive batteries to store it.
Right, it's a real-time balancing act.
Exactly.
Yeah.
So if everyone plugs in at 6 p.m. while the air conditioners are simultaneously blasting across the city, the demand instantly outstrips the power plant's generation capacity and the grid goes black.
And the sources show both regions actively fighting this scenario. In Dubai, drivers are being heavily incentivized with pricing structures to charge during off-peak hours like the middle of the night.
Just to smooth out that demand.
Right, to balance the city's overall energy consumption curve.
And the South Australian data paints an even more dramatic picture of energy management. The RAA notes that recent electricity cost shocks across the region drove a massive 69% surge in inquiries for home solar panels and home battery installations.
69%, that's a huge spike.
It is. Consumers are desperate to generate and store their own power independently from the volatile broader grid.
And because of this desperation, the RAA isn't just focused on cars breaking down on the highway anymore.
No, they're pivoting.
They are heavily expanding into commercial scale, solar, home batteries, and most crucially, they are advocating on the global stage. They pushed for something called bidirectional EV charging to be a major agenda item at the global COP31 climate conference.
This raises an important question, though, about what our cars are actually capable of.
Yeah, I am going to need you to explain this one clearly because reading the term bidirectional charging sounds great in brochure, but how does my car actually power my house? Is it just functioning like a giant extension cord?
Well, it requires a fundamental rethinking of what an electric vehicle is.
Right.
Cars store energy in direct current or DC power.
Okay, DC power.
But your house operates on alternating current or AC power. A bidirectional charger contains a specialized two-way inverter.
Ah, two-way.
Right. It allows the flow of electricity to completely reverse direction and translate the car's DC power back into AC power for your house's electrical panel.
So the car stops being just a mode of transportation.
Completely. Through vehicle-to-grid or V2G technology, the EV becomes a grid stabilizer.
How does that work in practice?
Imagine your car parked at your house during a sunny day. Your roof solar panels generate excess electricity, which the bidirectional charger feeds directly into your car's massive battery for free.
Nice.
Then the sun goes down. It is 7 p.m., everyone is cooking dinner, and the local utility is charging premium peak rates for grid electricity.
So power is expensive right then.
Very. Instead of buying that expensive power, your bidirectional charger flips. It pulls the free solar energy stored in your car and feeds it back into your house to run your oven and your television.
Wow.
You could even sell the leftover energy back to the city grid. It slashes your household utility bills by leveraging the battery sitting idle in your driveway.
So what does this all mean? It is genuinely wild to step back and look at the scale of this. We've traveled in this deep dive from the high-rises and on-demand mobile charging vans of Dubai, where absolute convenience is solving the density puzzle, all the way to the sprawling border-to-border rapid charging highways bridging the vast distances of South Australia.
It's two totally different worlds solving the same problem.
Yes. Whether you are prepping for a logistics meeting on delivery fleets or you're just insanely curious about what your next personal vehicle purchase is going to entail, the physical reality of the EV shift is not some distant sci-fi concept.
Not at all.
It is happening right now in the concrete pouring, the wiring being laid, and the behavioral shifts happening across the globe.
The infrastructure is physically being wrestled into the ground as we speak, forcing old electrical grids and ancient human habits to adapt to whatever extreme environment they find themselves in.
Absolutely. So as we wrap up today, I want to leave you with a final thought to mull over regarding that bidirectional charging concept we just discussed.
It's a fun one to think about.
It really is. Imagine a near-future scenario for yourself. A massive, historic storm rolls through your city and completely knocks out the local power grid. The streetlights go dark, the neighborhood goes silent.
A total blackout.
Right. In a traditional setup, you are sitting in the dark, watching all the food in your fridge spoil while you wait days for the utility trucks to arrive.
We've all been there.
But in this new reality, your electric vehicle sitting in the garage automatically detects the grid outage. The bidirectional charger seamlessly reverses the flow of power, discharging the massive energy stored in the car's battery back into your electrical panel.
Just kicking in instantly.
Exactly. It keeps your lights on, it keeps your fridge cold, and it keeps your entire life running normally for 3 straight days.
It's incredible resilience.
It is. In this future, your car isn't just transportation to get to work. It is a fully functioning personal power plant. When millions of citizens are driving their own personal power plants into the office every single day, what eventually happens to the traditional energy monopolies that have controlled our power for a century? Suddenly, you aren't just a consumer connected to the grid anymore. You literally are the grid.